Hello everyone, my name is Dmitrii Ivashchenko. I'm a software engineer at my.games. Today we'll navigate through the ECMAScript 2023 and 2024 features. We'll dissect their technical specifications and applications. Expect a detailed overview aimed at practical implementation. This session is designed to equip you with knowledge for direct application. And originally this talk was set for 2023, however due to rescheduling to 2024, I've included updates for both years. Our focus begins with the foundational updates of last year. So let's briefly explore the key enhancement introduced in 2023. In this part, we'll look at new methods for searching an arrays from the end, the hashbang grammar, introducing symbols as keys for weak maps, and new methods for getting a modified copy of an array. Let's start with the array find from the last feature. In arrays, we've now equipped with two new methods, findLast and findLastIndex. These methods enhance our toolkit by allowing us to search from the end of an array. This addition is particularly useful for scenarios where the most recent elements are of interest. It streamlines the process of finding the last element that meets a certain condition or its index without unnecessary array manipulations. FindLast method accepts a callback function. This is executed for each element starting from the end, and it continues until a truthy value is returned. FindLastIndex operates similarly but returns an index. An optional this arg can be used for the callbacks this value. This syntax is similar to find and findLast. However, it works in drawers from the end of the array. This approach is more direct in certain cases. Consider a number array like 2, 4, 7, 6, 9, and we want the last odd number. Using findLast, we target odd numbers with a callback. It returns 9, the last odd number in the array. And now think about the task sequence. Build, test, deploy, and test again. We need the index of the last test. FindLastIndex comes into play here. It returns 3, marking the last occurrence of test. These examples highlight the method's practical utility, especially in scenarios where the latest element matters. Now let's talk about the hashbang grammar standardization. This standard formalizes the use of hashbangs in JavaScript. Traditionally, CLI.js hosts handled hashbangs externally. This change brings the process into JavaScript engines themselves. It's about unifying and standardizing these across all environments. A hashbang looks special, like started with hash, placed at the very start. It's specifically designed for CLI JavaScript environments. This ensures scripts are correctly recognized and executed in such contexts. Remember, it's only valid at the beginning of the file. Now let's see hashbang in action. Imagine a Node.js script beginning with our hashbang line. This tells the environment to execute a file with Node.js. Similarly, a module can start with a hashbang for the same reason. These examples illustrate hashbang's role in defining script execution contexts. The next feature is symbols as weak map keys. This extension allows symbols as unique keys in weak maps. Previously, weak maps were limited to object keys. Symbols, being unique primitives, offer a new dimension. They enable more flexible and clear weak map usage. Let's look at the syntax for using symbols in weak maps. Create a symbol and use it as a key in weak map. Symbol myKey marks our unique key. Now let's consider practical application for this feature. First, using symbols for unique object configurations. Imagine different sortings for object 1 and object 2. Symbols ensure these configurations remain distinct. Next, consider creating membranes with shadow realms. A membrane might manage objects across execution contexts. Using symbols, we can reference these objects without confusion. These examples highlight the utility of symbols in weak maps, especially in complex cases like configuration management and virtualization. The next proposal is change array by copy. This feature brings new methods to the array prototype. These methods generate a new array with desired changes. The original array remains untouched, promoting immutability. This approach aligns with modern functional programming practices. Let's explore the syntax of these new methods. To reverses the array, creating a new copy. To sorted sorts the array, again as a new copy. To spliced allows for splicing, and method with updates a value at a specific index. These methods also extend to typed arrays, and let's delve deeper in these transformative methods. Reversing arrays often requires careful handling to avoid mutation, but to reverse elegantly sidesteps this, offering a reversed copy. Sorting type arrays similarly risks altering the source data. To source preserves the original, providing a sorted version. Splicing arrays typically involves direct modification. To spliced, introduced a way to insert elements non-mutatively. Imagine needing to insert 3 into 1 to 4, and to spliced makes this seamless. Occasionally we need to update just one element in an array. Traditionally, it might involve direct assignment, risk mutation, with changes the game by allowing targeted updates without side effects. For example, correcting 113 to 123 becomes trivial. So we've covered the features of ECMAScript 2023 and can now move on to the new features of 2024. The update greatly expands the capabilities of JavaScript. It includes well-formed Unicode strings, atomics wait async, and regex flag, array buffer improvements, and new methods that simplifies the creation of promises. We are navigating the concept of well-formed Unicode strings in ECMAScript. This addresses a common challenge ensuring strings conform to Unicode standards. ECMAScript strings consist of 16-bit code units, not always representing valid Unicode. Well-formed strings require correct pairing and ordering of surrogate code units. It's critical for interfaces with WebAssembly, network APIs, and file systems. Improperly formed strings can lead to errors and misinterpretations in these interfaces. Our goal is to streamline string validation, reducing conversion blunders. The proposal introduces methods for efficient, clear validation, enhancing code readability. This aligns JavaScript with broader web standards, fostering better interoperability. Let's delve into the syntax. Is well-formed checks if the string adheres to Unicode's well-formed criteria. To well-formed corrects with any anomalies, replacing ill-formed sequence with a universal placeholder. This ensures strings are compliant with Unicode standards, essential for many APIs. The validation process involves checking for properly paired surrogate code units. Ill-formed strings can result from unpaired or misplaced surrogate pairs. These methods offer a direct, understandable approach to managing Unicode strings. By standardizing those operations, we simplify string handling across diverse environments. Consider a JavaScript application interfacing with a Unicode-sensitive API. An ill-formed string could disrupt this integration, possibly leading to errors. For instance, a string containing a long surrogate would not be considered well-formed. Using isWellFormed, we can effectively check the string's validity. If found ill-formed, well-formed provides a straightforward correction mechanism. This replaces any problematic sequences, ensuring the string is compliant with Unicode standards. Such functionality is crucial for application dealing by internationalization for data actions. By facilitating these corrections, we enhance JavaScript's reliability in global applications. The next feature is Atomic's wait async, a small enhancement to ECMAScript Atomic's API. This new method allows agents to wait on a shared memory location without halting execution, particularly beneficial for environments where blocking isn't an option, like browser's main thread. Traditionally, synchronization in shared memory was limited to blocking operations. Atomic's wait async breaks this limitation by introducing a promise-based non-blocking alternative. This aligns JavaScript closer to the concurrent programming paradigms of modern web applications. It facilitates smoother integration of shared memory operations, improving both performance and user experience. Diving into the syntax, Atomic's wait async expands the atomic operations toolkit. The method accepts a typed array, an index within that array, a value to compare, and an optional timeout. If the value at specified index matches the given value, the operation synchronously waits. Upon completion, it resolves with an object indicating the wait's outcome, such as OK or timed out. This non-blocking wait is crucial for operations in environments that can't afford to be halted. It's designed with promise-based semantic to seamlessly integrate into a synchronous nature of JavaScript. Wait async thus provides a robust non-blocking mechanism to avoid changes in shared memory. And let's explore the practical application of wait async into web application. Consider a shared array buffer where multiple threads or workers might be operating concurrently. Using wait async, thread can asynchronously wait for a specific condition to be met in the shared buffer. In this example, a worker waits for the value at the first index of an array to change from 0. Once another agent modifies this value and issues a notify, the waiting promise resolves, login notified. This demonstrates how wait async enables efficient non-blocking coordination between threads. Such capabilities are invaluable for high-performance concurrent web applications where responsiveness and efficient resource utilization are paramount. Through this example, we see wait async not just as a feature, but as a facilitator of sophisticated concurrent web architectures. The next big change is the regex v flag with set notation and properties of strings. ECMAScript 2024 enhances regex capabilities, introducing set operations like difference, intersection, and nesting. Together with string properties proposal, it also includes Unicode string properties in the regex character classes. This development addresses a common problem with regex, the need for operations beyond simply combining characters. Developers can now craft more expressive, concise regex patterns, leveraging name character properties and set operations for refining text processing. This feature not only improves pattern matching, but also aligns ECMAScript with Unicode, regular special rules, promoting greater consistency and power when working with web texts. Delving into the new syntax, the v flag unlocks a new dimension in regex patterns. With this flag, developers can articulate complex character sets through operations like subtraction and intersection. For example, matching Greek letters and marks becomes streamlined with set intersections encapsulated in concise syntax. Subtracting ASCII from emoji set allows for filtering non-ASCII emojis, refining the character selection process. These operations, coupled with the ability to nest character classes, offer unprecedented precision in pattern definition. The V flag serves as a key to these enhanced syntax, marking the pattern for advanced processing and enabling these novel operations. Consider the task of identifying non-ASCII digits in internationalized content. The new syntax allows for a straightforward expression to match these characters, including their familiar ASCII digits. Similarly, in typography and text layout, distinguishing breaking spaces from non-breaking varieties is crucial. The advanced regex features enable precise identification for such spaces, excluding specific categories like glue. These examples illustrate how the V flag and associated syntax enhancements empower developers to tackle complex text processing tasks with elegance and efficiency. By enabling more expressive and targeted pattern matching, ECMAScript's regex functionality becomes an even more valuable asset in the developer's toolkit. The capabilities of array buffers in ECMAScript have been enhanced, adding resizing and incrementing capabilities. This major update allows buffers to be incremented and decremented in place, marking a leap in efficiency memory management. Traditionally, increasing an array buffer required allocating a new buffer and copying the data, which was an inefficient and memory fragmenting process, especially on 32-bit systems. With the ability to make changes in place, we not only simplify the memory management process, but also reduce fragmentation, improving performance. Moreover, this feature harmonizes ECMAScript's array buffer with WebAssembly's memory management, allowing streamlines interaction and data transfer between the two. Array buffer and shared array buffer now take a max length as a second parameter. This lets the buffer grow without copying data. Array buffer can be resized up and down with the resize method. Shared array buffer can only grow with the grow method. These features aim to boost performance. They pre-reserve space which gets used as needed. This makes managing memory easier, especially for WebAssembly and WebGPU, and dynamic memory handling becomes more straightforward. You start with a moderate-sized array buffer. As data grows, you need more space. Use the resize method to make the buffer bigger. This avoids the slowdown from making new buffers and copying them. It's great for fast ongoing data tasks. Shared array buffers are for when many threads work together. They can grow with the grow method. This way, all threads see the updated size. It keeps data in sync across threads. These changes make memory use better and more flexible. The next one is the array grouping proposal, now part of ECMAScript 2024. It introduces a simpler way to group array elements. Imagine sorting numbers into even and odd categories. Object group by does this by assigning items to keys. For more complex keys, map.groupBy uses map instance. These features streamlines data organization akin to SQL's group by. It's ideal for computing datasets like average ages or daily metrics. Both methods enhance data analysis, offering structured, accessible grouping. This proposal enriches JavaScript, making data manipulation more intuitive. Group by categorizes elements by key, determined in a callback. In our example, numbers are sorted into even and odd. The result is an object with groups as properties. For complex keys, map.groupBy comes into play. It returns a map, allowing object-based keys for grouping. This method shines in scenarios requiring detailed categorization. The syntax is straightforward, yet powerful for various use cases. These grouping methods promise to simplify complex data operations. Now let's see these methods in action in real-world examples. First, consider grouping an array of numbers by evenness. Using object group by, we easily separate them into even and odd. This method is perfect for a quick, straightforward categorization. Next, imagine needing more nuanced grouping using complex keys. Map.groupBy allows us to use objects as keys for such groupings. This capability is crucial for detailed, multi-attribute categorization. The next ECMAScript addition is promise.withResolvers. It's a straightforward method to create promises. No more complex executor callbacks needed. Directly access, resolve, and reject to control promise outcomes. This feature is for when post-promise creation control is needed. It streamlines scenarios needing external resolution control. Invoke it directly from the promise constructor. It returns object containing promise, resolve, and reject. No need to wrap in resolve and reject in an executor. This method is clear, concise, and efficient. It suits varied scenarios from event handling to asynchronous requests. Adopting these methods reduces boilerplate and enhances code readability. Now let's see promise.withResolvers in action. Imagine handling an asynchronous fetch request. Use resolve and reject to manage fetch outcomes directly. This approach is clean, simple, and effective. Consider the next scenario with socket communication. Assign resolve and reject to data and error events, respectively. This method ensures straightforward and reliable event handling. Promise with resolvers empowers developers in various asynchronous situations. The last feature is arraybuffer.prototype.transfer. This method improves how we handle array buffers, allowing for efficient ownership transfer. It detached the original buffer, preventing further modifications. The method is designed for optimized reallocations, mimicking realloc semantics. It's particularly handy when working with resizable array buffers, fixing them into fixed-length format. This addition fills a gap, providing a programmatic way to transfer array buffer similar to HTML serialization algorithms. Let's break down the syntax for these array buffer transfer methods. ArrayBuffer.prototype.transfer creates a new buffer with the same content as the old, up to a specific length. The original buffer is then detached, preserving its maximum length in the new buffer. For scenarios where a fixed-length buffer is desired, transfer to fixed length comes into play. This method always returns a non-resizable array buffer, ideal for finalizing the buffer size. Both methods are geared towards performance, potentially allowing copy-free moves or realloc operations. These APIs offer developers precise control over array buffer manipulation, optimizing memory usage in web applications. Now let's explore how these array buffer transfer methods can be applied. Imagine a scenario where you need to pass array buffer ownership securely. Using transfer, we can ensure the original buffer is no longer accessible post-transfer. This method is invaluable in scenarios requiring strict data ownership and integrity. In another case, you might need to resize an array buffer for additional data. Transfer allows for efficient reallocations, mirroring real logs behavior without manual copying. And when a resizable array buffer size is finalized, transfer to fixed length log sits down. Moving forward, we'll summarize the key takeaways and the overarching theme of these updates. So we've looked at updates for ECMAScript 2023 and 2024. 23 brought us easier ways to search arrays and new syntax features. It also made working with arrays and data keys better. 2024 is all about making JavaScript more powerful. We are getting better ways to handle strings and perform tasks without waiting. New regex features let us match patterns in advanced ways. We can now change the size of data storage as needed. Grouping data and managing promises got a lot easier. There is even a new way to move data around efficiently. All these updates make coding in JavaScript smoother and smarter. They are about solving real problems and making our code better. So finally, I just want to say thank you for your attention, and also thank you to XtremeJS for hosting me. If you have any questions, feel free to ask or contact me later, and see you next time!